Hi students, we are beginning a new chapter, Chapter 8, working with exponents. Our first section of Chapter 8 is multiplication properties of exponents. So there are three different types of multiplication properties of exponents. The first one is called the product of powers property. And what that means is you are going to multiply powers that have the same base by adding the exponents. So if we look at our example right below this here, we have a to the m times a to the n. Notice my base is a, that is the same, a is the same, but my exponents are different. So I'm going to add those, m plus n. So if we have it working with numbers here, we have 3 to the second times 3 to the seventh. We have the same base, which is 3. So we're going to add the exponents, 2 plus 7. So my answer here is going to be 3 to the ninth. The second property is called power of a power property. And what that means is you are going to find the power of a power by multiplying your exponents. So look at our example here. We have a to the m. Then we have the parentheses. And outside the parentheses, we have our n. And what you do with m and n, you multiply them. When you're given the parentheses like that, you multiply. When we're given numbers, for instance, here we have 5 squared in the parentheses and outside to the fourth, raised to the fourth power. So we're going to multiply 2 times 4 to get 8. So that's going to be 5 to the 8th power. Our last property is called the power of a product property. And you are going to find the power of each factor and then multiply it. So for instance, here in the parentheses, we have a times b raised to the m power. So what we need to do is we need to have m go to the a and m go to the b. So what you have is a to the m times b to the m. So for instance, if we have 2 times 3, we're going to do 2 squared. We're going to do 2 to the 6th. The 6 goes to the 2 and goes to the 3, and then 3 to the 6th. So that would be my answer. So let's practice some of this so this makes a little bit more sense. So our first examples here, we're working with the product of powers property. So we have to look and see if our bases have the same number, and if so, we can add the exponents. Here for a, we have 3 to the 5th times 3 to the 2nd. So that's going to be 3 to the 7th. Since my base is the same, that stays as 3. We add my exponents, 5 and 2 to get 7. Notice for B, we're not working with numbers for my bases. They're variables, but same idea. When we don't have an exponent, like for instance, z here, we have z times z to the 2nd times z to the 4th. Think of this as z to the 1. So my answer here is going to be z, because my base is the same, and I add my exponents, 1, 2, and 4, and I get an exponent of 7. For C, we have 5 times 5 to the 5th. Think of this as 5 to the 1st times 5 to the 5th, which is going to give me 5 to the 6th. And then for D here, we have negative 3 times negative 3 to the 5th. Notice there's no exponent here. Think of this as 3 to the 1. My bases are the same, negative 3. So that's going to be negative 3, and then 5 plus 1 gives me 6. And that'll be my answer. We're now going to look at examples working with power of a power property. So here, notice we have the parentheses, and what we're going to be doing is multiplying the exponents. So for A here, we have 4 to the 2nd power, and then outside the parentheses 4. So technically that's going to be 4 raised to the 4 times 2 is 8th power, and that will be my answer. B, we're going to multiply 3 times 5 and get an answer of y to the 15th power. Now notice for C, we are given the parentheses, but we also have our brackets. What you're going to do is you're going to multiply 3 and 5 here within the parentheses and brackets, and we'll just write my base. So my base is negative 4, and then 3 times 5 is 15. So that is my final answer, negative 4 raised to the 15th power. Example 3, within example 3, we're working with power of a product property here. So what we have to do is we have to distribute this exponent to each situation in the parentheses. So for A here, think of this as 3 to the 4th, which means 3 times 3 times 3 times 3. 3 times 3 times 3 times 3 gives me 81. Then it's going to be x to the 4th and y to the 4th. Remember, we have to bring that exponent to each variable in the parentheses here. Looking at B, we have in the parentheses negative 3y raised to the second power. That second power gets distributed there to the negative 3 and to the y. So what we think of this as negative 3 squared times y squared, which is negative 3 times negative 3, which gives me 9. Y to the second power. That'll be my answer. For C here, notice my negative sign is outside the parentheses. So solve what's in the parentheses with the exponent first. Think of PEMDAS. Please excuse my dear Aunt Sally. And then we'll bring the negative out for our final answer. So we'll distribute 2 to the 3, and to the y. So what we have here is 3 squared and y squared. 3 squared, 3 times 3 is going to give me 9. But don't forget, now we'll bring that negative back out in front there. So it's technically negative 9 times y to the second power. And that's my final answer. And the last example here, example number 4, we're bringing all the properties we just learned about in this section together. So if we look here, we have in the parentheses 3x to the 4th times y squared. This is a multiplication sign, times y to the 5th. So what we need to do is distribute that square, that exponent of 2, to each situation in the parentheses here. So what we have is 3 squared times x, then we multiply 4 times 2 to get x to the 8th, and y squared times that by y to the 5th. Okay? 3 squared is going to give me 3 times 3 is 9, x to the 8th. But notice I have like bases. I have y to the 2nd and y to the 5th. So that's, since we have like bases here, we'll write y and we can add those exponents. So it would give me y to the 7th then. And this would be my final answer when we combine all those properties together. That is it for this section.